Moist air at 25 C, 100 kPa at 70% relative humidity is continually drawn into an air compressor. This is a very practical problem. Anybody ever seen an air compressor? Hopefully you all have. And so it sucks in outdoor air, or wherever, if it's in a building, whatever the room's air is, it's drawing it in. So think of 25 C, 100 kPa, 70% relative humidity. And it boosts the pressure up to, let's say, about 900 kPa. I would say that's, I picked it around 120, 130 psi. So that's very reasonable. That would be the pressure in the tank. And if it just sits in the tank a long time, you have a big tank, it'll really cool down. I know it comes right out of the compressor hot, but if it sits in the tank for a while, it cools back down. And the lowest temperature to cool back down to is the ambient temperature. So just to say, it eventually cools back down to 25 degrees C in the tank before being drawn from the tank, piped over to some shop tools, and used. Because there's a lot of pneumatic tools being run, and like air guns, you know, for removing nuts and the tightening nuts in factories. There's a lot of pneumatic tools out there. So you have a compressor, then it basically a heat exchanger, and it sits in this tank for a long time, and then eventually it's drawn off. And so what's drawn in eventually is used. Okay, think of continuously being run. It's continuously running. I know that these things run, then shut off, then run, then shut off, based on keeping the pressure of the tank high, but think of it just continuously running. It is known that the water will collect in the bottom of the compressed air tank. Anybody had experience like that? Yeah. It's a shocker. You'll own a compressor. They'll have a little cock valve on the bottom of that, and they'll tell you need to open that cock valve and drain the tank every now and then. No, that's when you shut it off and the pressure drops a lot and you're not trying to open it when it's running. They do have automated systems where they have a blowdown, and it'll just go and then shut off. So it'll periodically do a little blowdown to try to keep the tank dry. But if you just own a compressor, it doesn't have a blowdown, you'll have to open up this cock, and the first time you do it, especially on a hot, humid summer day, you're a little surprised. Where did all that water come from? It came out of the air. And with the tools that we studied in this class, we can analyze this problem. So the question is what is the amount of liquid water collected in the tank per kilogram of air drawn into the compressor? You draw in 1 kilogram of air. Let's even call it dry air. Okay? With that dry air, you're going to get some moisture with it. Then it's going to be basically, it's going to be saturated air here that's going to get drawn off, but you'll get some condensate collect in the bottom of the tank. True? Some condensate. So let's just do a big control volume like this. There's our control volume. We know that there's some work in. We know that there's some heat transfer out. But what comes in is our 25 degrees C and 70% relative humidity air. And what goes out is 25 degrees C air at this pressure is critical. Sorry about that. That's 100 kPa. This pressure is critical, 900 kPa. And the condition of this is it's saturated air. You want to send air to the tools. You'd prefer it to be very dry, but without any dryer system, any desiccant system on it, it's going to send out saturated air, and there'll be some water in the bottom of the tank for this condition. Okay. So what do we do is if you do a analysis of this, you'll say, what is the omega coming in? What is omega? It's how many kilograms of vapor per kilogram of dry air. Well, it's 0.622 PV divided by P dry air, true? So a little bit of work. What is PV? Well, it's phi times P sat. at the 25 degrees C. And then maybe you just skip this, just call it the total pressure minus PV, because it like eliminates one little step. Okay? So that's the humidity ratio coming in. My calculations say that this is 0.0141 kilograms of vapor for every kilogram of dry air. Now, what about the humidity ratio going out? State 2. Well, you would do the same thing. You would want to have 0.622, the actual vapor pressure divided by the P minus PV. This P now is your 900 kPa. True? It's our 900 kPa, isn't it? All right. Well, what is PV? PV is 100% of the saturation at 25 degrees C. We could have changed the outlet temperature, but just leave it 25 degrees C. So the vapor pressure going out is 3.17 kPa. And when you go back and calculate this omega, it's 0.0022. Just compare these numbers. 141 versus 22. So the difference is omega inlet minus omega outlet is 0.0119 kilograms of water, which now they're going to have to be condensed. That's where they're going. They're going to go to liquid per kilogram of dry air that goes through the compressor and tank. That difference. So this is the mass of liquid that's put into the tank per mass flow rate of dry air flowing through the tank. So I had this in Excel 2. It's right here. So if you put in 2,500 kPa relative humidity, you can calculate all that, and there's the omega. 25,900, that's the big difference. And you have omega very much lower. See that? And the partial pressure is higher. Look at this. The partial pressure of the vapor is higher. It used to be 2.2, now it's 3.17. But the total pressure is so much higher that your omega is much lower. And so that's what comes out per 1,000 kilograms of dry air. You could play around with this. Let's say, oh, I don't think it goes out at 25. Maybe it goes out at 35. Then you can hit return, right? And you see it just changed the results. Okay, somebody says, we rarely have such a humid day in San Antonio, and I think, very rarely is it that hot with that percent humidity. Fine, put it 50%. So it changes how much moisture, how much liquid you're going to get into the tank. Some days, if you run air compressor with some tools, like my boys will have a nail gun and they'll work outside. And then at the end of the day, they open the cock, not much comes out. It's a hot, dry day in San Antonio. Okay, but then some days, a lot of water comes out, but it's a humid day. So you can just play with this. There's another feature here is, if it's 25 degrees C and 75% relative humidity, okay, what temperature should you go out at? This, maybe 45 will be where you're driving this to zero right here. Maybe that's 55. Maybe that's 75, Okay, whoops, I went over that. Control Z. 75. Okay, and so that is over that, about 65. And so what you're doing is I'm doing a root search by hand. Come up to data, what if, goal seek, set that cell equal to 0 by changing this cell, and it comes in at 61.5 degrees C. So if you do supply warmer air to the tools, then it takes more moisture with it. But if you have a shop and you use a lot of compressed air, they'll have a filter dryer system on that compressed air system, or they'll end up replacing a lot of air tools.